Welcome my dear students. So in this session we are going to see about dimensional analysis. So first let us see about what is meant by this dimensions. Okay. Dimensions of physical quantities. Dimensions of physical quantities. So now, what is meant by this dimensions? Okay. So if we represent the physical quantities in terms of powers of base quantities, then it is called as dimensions. Okay. So if we represent the physical quantities, in terms of powers of base quantities. Base quantities are also called as fundamental quantities. Okay, so if we represent the fundamental quantities in terms of power, then that is called as dimension. For example, if we take velocity, v is equal to lt power minus 1. This lt power minus 1 is the dimension for velocity. So why we are saying is that it has dimension, because this L and T are the fundamental quantities, or we can say it as base quantities. These two are the base quantities, L for length and T for time. These fundamental quantities are raised to some power. So here the power is 1 and here it is minus 1. So the base quantities raised to some powers, then we call this as dimensions. Okay. So dimensions of physical quantities. So physical quantities like length, mass, time, velocity, acceleration, these quantities can be expressed in terms of a few base quantities like mass, length and time. Okay, so the physical quantities like length, mass, time, velocity, acceleration, etc., they can be represented in terms of three fundamental quantities: mass, length and time. Okay, using the dimension of these quantities, we can write the dimension of the physical quantities. The dimension of mass is m. The dimension for length is L and for time it is T. Okay, so while representing dimension, we have to write this in square bracket. Okay, like this. So the dimension of mass is M. The first letter you have to remember. The dimension of mass is M. The dimension of length is L. And the dimension for time is T. Okay. So using these M, L and T, we can find the dimension of other physical quantities. Okay. So first of all, let us find the dimension for velocity. So, you may be asked in your exam, what is the dimensional formula for velocity? So, how can we find the dimensional formula? To find the dimensional formula, first we have to write the expression for that. Okay. The first step is to write the expression. What is the expression for velocity? Velocity is equal to displacement by time. Okay, displacement by time. So what is this next step? The first step is to write the expression. The second step is to write the dimension for each quantity used. What is the dimension for displacement? So displacement means it is also the distance, right? So here for distance, we have to write the dimension L. Okay, L. For time, the dimension is T. So dimension we are writing square brackets. Okay. So what will you get here? L. This T, if you bring to the numerator, it becomes T power minus 1. So this is the dimension for velocity. L T power minus 1. Or we can also write this as M power 0 L T power minus 1. So m power 0 in terms of mlt. If we want to write, we don't have the term m, so it is written as m power 0. M power 0 means it becomes equal to 1. Okay, then lt power minus 1. Okay, so the dimension for velocity is lt power minus 1, or we can write it as m power 0 lt power minus 1. Okay, the second one we can find for acceleration. How can we write the dimensional formula for acceleration? So how will you find the dimensional formula? First step is to write the expression. Okay, acceleration is rate of change of velocity. So it is velocity by time. So first step we have written the expression. Okay, next we have to write the dimension of each physical quantity. So next step, what is the dimension for velocity? We have already found it as lt power minus 1 by t. Okay, so what it is? L, this t power minus t power 1, when it comes up it becomes t power minus 1. So already here is one t power minus 1, so it becomes L t power minus 2. Or in the other way, how can we write it as m power 0 L t power minus 2. So you should have in mind for velocity, the dimension is lt power minus 1. For acceleration, it is lt power minus 2. Similarly, the third one which we are going to find is momentum. Okay, momentum. Momentum P is equal to mv. We know that P is equal to mv. So what is the expression? Mass into velocity. Okay, mass into velocity. So we have written the expression. The next step is to write the dimensional formula. What is the dimensional formula for mass? It is m, and for velocity it is lt power minus 1. So we can write it as m l t power minus 1 is the dimension for momentum. Okay, the next thing which we are going to find is force. Force F is equal to ma. Okay, so it is mass into acceleration. Mass into acceleration. Next step is to write the dimension. What is the dimension for mass? Capital M. Into what is the dimension for acceleration? Lt power minus 2. So it is m lt power minus 2. Okay, for the dimension for force is ml t power minus 2. Then the fifth one is pressure. How can we find the dimension for pressure? The expression is pressure is equal to force by area. Force by area. So we have already derived for force, it is ml t power minus 2 by area, length into breadth. So it is length into breadth. So L into L, it becomes L square. So what will you get? M, this L and one L gets cancelled. So it is M L power minus 1 T power minus 2. Okay, so these are the very important dimensional formula. So this you should have in your mind always. For velocity, it is Lt power minus 1. Acceleration, Lt power minus 2. Force is very important. Force, ml t power minus 2. ml t power minus 2. Pressure, it is m l power minus 1 and t power minus 2. So, we have seen about the dimensions of physical quantities and how to derive the dimensional formula. Okay. Next we are going to see how to classify the quantities on the basis of dimensions. Okay. On the basis of dimensions, how can we classify the physical quantities? Okay. So this on the basis of dimension, we can classify into four types. Okay, the first one is dimensional variables. Dimensional variables. The second one is dimensionless variables. Dimensionless variables. The third one is dimensional constants. Dimensional constants. And the fourth one is dimensionless constants. Dimensionless constants. Okay. So we have classified into four types on the basis of dimensions. What is the first one? Dimensional variables. The second one is dimensionless variables. So in this variables itself, we have two types. One is dimensional variables, another one is dimensionless variables. Okay. So like that, in constants we have two types. Okay. In constants we have dimensional constants, dimensionless constants. So now we are going to see what is this dimensional variables. Okay. So from the name itself you can say. So dimensional variables means they are physical quantities whose value vary. Variables. So that value will vary. It's not a constant. The value varies and also it have dimension. The value should vary and it should also have some dimension. Those quantities are called as dimensional variables. For example, the physical quantities like length, area, velocity, acceleration, these are all called as dimensional variables. Why we are saying it as dimensional variables? Because these variables values will change. It's not constant. We can't say always the length is 10 centimeter. The length may vary. So these are all having different values. So they are called as variables. And this should have some dimension also. Okay. So length has a dimension L. Area has the dimension L square. Velocity has LT power minus 1. So this come under the type dimensional variables. Okay. So what is the second one? Dimensionless variables. What is this? Dimensionless variables. So they are variables but they should not have any dimension. Okay. Variables that does not have any dimensions are called as dimensionless variables. So the value it changes. Value changes but they don't have dimension. For example, strain, refractive index, refractive index. These are all examples of dimensionless variables. These refractive index, strain and all, they have some value. Okay, they have some value but they don't have any dimension because they don't have any unit. So they don't have any dimension. Okay, the third type is dimensional constants. So dimensional constants, from the name itself we can say they are constants and they have dimensions. Okay, constants which have dimensions are called as dimensional constants. For example, you can say gravitational constant, gravitational constants, then Planck's constant, Planck's constant. Okay, Planck's constant. These are all dimensional constants. Okay, why we are saying so? This gravitational constant, it have a value 6.6 into 10 power minus 11 n m square kg power minus 2. Planck's constant, the value is 6.62 into 10 power minus 34 joule second. So this value is a constant. It's a constant. It does not change. Okay. And it also has dimension because it is having unit, no? So definitely it will be having dimension. So constants which have dimensions are called as dimensional constant. Example, gravitational constant and Planck's constant. Then what is the fourth one? Fourth one is dimensionless constants. Dimensionless means they don't have dimension but their value is constant. Okay. For example, pi. So we know the value of pi is 3.14. So it's a constant. Okay. And it does not have any dimension. So it comes under dimensionless constant. Okay. So what are the four types? First one is dimensional variables, dimensionless variables, dimensional constants, and then dimensionless constants. Okay, so hope you have understood about this dimensional analysis. So we have seen today how to find the dimensional formula of physical quantities and how the physical quantities are classified on the basis of dimension. Okay, hope you have understood well. If you like this video, please like, share, and don't forget to subscribe. Meet you in the next video. Until then, it's bye from Anandi. Bye.